In this video, we're going to look at resistors in series and parallel, and I'm going to make it super easy for you to understand this. So let's start with series circuit. So a series circuit is what happens where everything is in one loop. So we've got two resistors, we've got a 20 ohm resistor and a 10 ohm resistor. And the way to analyze circuits is to think about what the current is doing. So I've put on some arrows there. We've got the current flowing from negative to positive. So this is electron current. So this is how the electrons are actually flowing in the circuit. And so when you think about it, those electrons are actually experiencing all of the resistance in that circuit. So when we want to find the total resistance, which we call RT, it's just a case of adding them up because the current is physically having to flow through both of the resistors. So in series, you may see in a textbook that the formula is written like this, and it's maybe perhaps a little confusing to start with, but basically what that formula is saying is that RT is equal to R1 plus R2 and then just plus R3 plus R4, and it goes on forever until you've got to the number of resistors in the circuit. So in this case, we have two resistors, so you're just doing 20 plus 10. But if you add other resistors, you just keep adding them up until you've ran out of resistors, and that's how a series circuit works. In a parallel circuit, you get some other problems going on. So if we think about how the current's flowing, comes out the battery like that, so this is the electrons, comes down there. Now something strange happens. The current here has a choice. Some of the current goes to the 20 ohm, and some of it is going to go down the way. So what's actually happening is that not all of those electrons are actually experiencing each resistor. So when we fill in the remaining bits for the path of the current, you can see that the 20 ohm is getting some of the current, the 10 ohm is getting some of the current, and then the current is recombining at the second junction and then flowing back to the battery. So the key thing in parallel is that you can't just add those two together because each resistor is experiencing a different amount of current. So the current isn't actually flowing through both those resistors. So that is why we have a different formula. So if we want to calculate the total resistance in parallel, there is a really powerful formula that we can use. And so I always use it this way. This is perhaps different to how your textbook's written it, but this way is far faster, and you can simply just type it into your calculator. So the total resistance is you're doing 1 over R1 plus 1 over R2 plus, and you just keep this pattern going over, 1 divided by your next resistance plus 1 divided by your next resistance. And then every single thing here is raised to the power of minus 1. And so this flips the fraction for you. So sometimes your teacher might teach you that you've got to flip it. If you use this formula, you don't have to do this. This formula is so much faster. So I'd recommend you use this formula. And so all we need to do is replace all of the R's in the formula with the actual numbers. So that 20 ohm is going to go in there. The 10 ohm is going to go in there. So when we do the substitution, we end up with this formula. We don't need to keep adding anything because we've got two resistors. So you're going to have two terms in the formula. And we raise that to the power of minus 1. So you can just type it in your calculator, and you want to make it look like this exactly. So you need to use the fraction button and the brackets button. Make sure you add the brackets first and then the fractions. Put everything to the power of minus 1, and when you type that into your calculator, you get the final answer. And so that's how you do it in parallel. Some questions are a little bit more sneaky. So you get 3 resistors. So you've got to appreciate how to use the formula a little bit more. So in this case, you've got RT is 1 over R1 plus 1 over R2 plus, and you just keep that pattern going. So you can see here that the third term is 1 over 30. So we've got the 20s going on the bottom here, the 10s going on the bottom here, and the 30s going on the bottom here. And if we had 4, you would just have 4 terms. We had 5 resistors, you'd have 5. And we raise everything to the power of minus 1, and that gives us that answer. I've rounded it. That would actually continue forever. But simply substituting all those numbers on the bottom, raise everything to minus 1, and you get the answer. There are some questions, however, that are even more difficult. We've got series circuits and parallel circuits. So you've got to be very careful with what's going on here. And so if we go back to our understanding how the current is flowing around the circuit, so we've got the current coming out like that, then the electrons are going like that. Then, of course, it's going to be splitting. So only some of it is going through the 20 and the 10, and some of it is going through the 20 at the bottom. So if we fill in the rest of it, that's our picture of how the current's flowing. But what we can see in the middle is that this bit of electron flow here is going through both of these two. So this is series from this perspective of this current, whereas down here, you've got a separate loop. So these two are in series with each other, but the combination of these two is in parallel with the 20 ohm. So what we can simply do is combine these two into one equivalent resistor. And we know from earlier that the formula for resistance in series is just simply adding them. So we can combine that, and we've now got a 30 ohm. It was 10 plus 20 giving 30. We've now got two parallel resistors, and so we use our magic formula to the power of -1. And then when you put that in your calculator, you'll get 12 ohms, and that is the final answer. So hopefully this has cleared up how to work with series and parallel resistors and find the total resistance. I'd strongly recommend you use the formula to the -1. I find it a lot quicker, and you can type it straight in your calculator. So hopefully this was helpful to you. And finally, thank you very much for watching.